In this video, we're going to take a look at products and quotients of functions. Now, the products and quotients of functions means that we're going to combine two functions by multiplying or dividing respectively. The product of functions is written as f times g of x, but can be expanded to be f of x times g of x. Similarly, quotient of functions is written as f divided by g of x, which then can be expanded to f of x divided by g of x. Now, the domain of a product of functions is the domain that is common to the original functions. However, the domain of a quotient of functions must take into consideration that division by zero is undefined. Let's take a look at an example here. So we have f of x equals to the square root of x minus 1, and g of x equals negative x plus 5. The domain of f of x, since we have a square root, we know that we have to square root a positive number, so x is such that x has to be greater or equal to 1, but it can be all real numbers otherwise. The domain of g of x, since this is a line, we have that x is such that x can be anything, all the real numbers. Now, the domain of f of times g of x is then x such that x is greater or equal to 1, and it can be all real numbers. However, the domain of f divided by g of x, we know that we still have to consider that the numerator will be the square root of x minus 1. So x will be such that x has to still be greater or equal to 1. But then in the denominator, we're going to have g of x, which is negative x plus 5. So therefore, x cannot equal 5 though. But it can represent all the other numbers that are greater or equal to 1. Now, so that you can have a better visual, let's take a look at the two graphs here. So this first graph here, I'm going to outline this in blue. This is the square root of x minus 1. And then we have negative x plus 5, which I'll outline in red. So that's g of x equals to negative x plus 5. Then when we combine them together, we get this graph here, which I will outline in green. And this is f times g of x. Taking a look at the functions divided, we have, again, our f of x equal to a root x minus 1, and then we have our line, so different from the first graph where we had the product, and we can see that x was greater or equal to 1 because it starts at 1 and then it kind of goes up and then it shoots down. We have the quotient, and when we divide, it does show that the graph is greater or equal to 1 as this graph goes up, and then there is an asymptote at 5, which we can see right here, which I'll draw in. But then the graph continues on like this. So this is our f, not times, this is our f divided by g of x. Let's take a look at another example. So here we have f of x equal to 3x squared minus 1, and g of x equal to 5x plus 2. So let's find f times g of x and f divided by g of x, and also state the domain and range. So recall that we can take this to be f of x times g of x. So this means that we can take 3x squared minus 1 and multiply that by 5x plus 2. So when we do that, we get 15x cubed plus 6x squared minus 5x, and then minus 2. So this domain is easy to find because we can see that this function is a polynomial. So we have x such that x is all the real numbers. And since this is a power 3, we also know that y is also all the real numbers. If it were an even power, you'd have to find the lowest value because the graph would either be pointing up, or if it was an even power where the graph points down, we would have to find the maximum value. Now the division one is a little bit tricky here in terms of finding domain and range, but let's find our function first. So we have f of x divided by g of x, and that gives us 3x squared minus 1 and 5x plus 2. Now the original functions, this had a domain of all real numbers, and so did the line, but the range was y is greater or equal to -1, but this one was y is all real numbers. So when we take a look at the domain here, we can see that we can choose any value for x. However, x cannot be -2/5, otherwise we will have 0 in the denominator, but it can be all the other numbers. Now the ranges are really tricky to find, and you have to kind of use your reasoning, but I think the most helpful thing is actually to use a graph. So let's consider the graph, which I have here, graphed in Desmos. So we can see that the red graph is our parabola, and our blue graph is a line, 5x plus 2. So now what I'm going to do is I'm going to combine them to have our quotient. So I'm going to type this out as y equals 3x, and we're going to square that, and minus 1, and then we're going to divide that by 5x, and then plus 2. So this is a kind of a different graph, one that we haven't really encountered before. So you can see the green lines here, and you can see that the domain is all real numbers, and that the range here also, the domain isn't all real numbers except for at -2/5, but we can see that the range, it covers all the values. So I'm going to hide the keypad here. You can see that it starts very low at a very large negative number, and then it goes up to the right. But even on the left side here, we can also see that it goes from a relatively large negative number, and then it also goes up. So we can tell from the green graph that the range is actually all real numbers. So definitely, I find it useful that if you can graph the quotient, then it'll make it easier for you to find the domain and the range, especially if you don't understand what the function looks like. So let's go back to here, and then now we can say that our range is all real numbers. And to remind yourself, you might want to just draw a little graph on the side here. Oh, I should have a asymptote at -2/5, and then something that looks like this.